Now let's go on and look at activity 3. So, for that, I'm going to get a weight and a weight holder. Do we have scales? Okay, so great, and a scale. And just to make sure everything is going right, I'm going to, weigh my thing. So basically, I let it turn on without anything on it. I have 0, so it's properly taired, meaning properly zeroed. So a little calibration there. So I'm calibrating my weight, and I've got 50-ish grams there. That's good. That's what I want. And when I put my 50 gram weight on the a weight holder, okay, I've got 100 grams. All right. So what I'm going to do then is, there's the interesting part of this part of these activities, and there's the boring part. And I'm about to do the boring part, and the boring part is boring because I'm not going to let anything move. Okay, so I'm going to put this 100 gram weight on. Do that. There we go. I think that will work. We'll see. There. And with this particular exercise that I'm going to do here, it's very important that we have the strings going through the grooves in the wheels. Of it, other parts of this lab, you can kind of get away with not, although you get some peculiar numbers, you can still potentially draw conclusions from it. But this part, okay, so I'm going to have this just sit there, and so let's see. Okay, so let me collect, and if it's just sitting there, notice that my force is just a little bit under 1. That's what I want. That means that my force probe is properly calibrated, and so that means we can continue the process. If we had a different graph, that would have meant that I would have had to done some fancy recalibration of the force probe. That I would have probably just swapped force probes. Anyway, okay, so now we are going to get maybe, oh, do we have to, here we go. Okay. We are going to get a long black bar and a short black bar, okay? And for this, and a green rubber band. And for this activity, I'm just going to use the short black bar. For the next activity, I will use both the long and the short black bar. Okay, so I'm going to put my short black bar on the cart with the motion detector, and then maybe I this way. There we go. Okay. I think that would make it easy to work. Okay, and then once I get the green rubber band on, then I can put on the short black bar and the short weight here. And then I'll take this and weigh the whole thing. And I find that it's easier to get an accurate weight if I weigh it upside down. It's pretty stable that way. Okay, so I've got 962 grams. The lab is going to ask for kilograms, so you want to put 0.962 as the number of kilograms. All right, so now for the exciting part. Let's see. I need to adjust the weight on my weight holder there, and I believe it says to put on let's see, it's hidden here somewhere. Oh, I'm looking at the wrong section. Okay, says to yeah, put it on 100 kilograms, should be about a Newton. Speculate as to what we're going to see when we do the experiment. You're not going to be able to really do that because I'm about to show you what we're going to see. Okay, so 140 grams is what I want on there. So I'm going to go get two 20-gram. I think that's 20. No, that's 10. Yeah, okay, 220-gram weights. And again, just make sure to make sure that I've chosen things properly. I'm going to put my weights on there. I'm going to weigh my thing. Okay, 140 grams, that's exactly what we want. Okay, so we're good. Okay. All right. Okay, and I lucked out. My string is still going through the grooves on the wheels. And so basically, what I'm going to do is I'm going to release the cart. It's going to, the weight that I've attached here is going to pull on the cart. It's going to hit the cart catcher there and stop. So I'm going to have three portions of the motion of the cart. One, before I release the cart. Two, while it's being pulled along. And three, while it's being caught by the cart catcher. And we're going to have to identify those three portions of the motion. So, if you could hit collect there. Okay. Let's do an adjustment of the velocity graph here, just so we can see it better. And also I'm going to do an adjustment of the force graph. Okay. I'm not going to adjust the acceleration graph because it's got that dip and it'll be bad. So what I'm going to look at then, several things. One is, all right, we again have this region where nothing's happening, and that's where I'm still holding on to the cart. Then I release it. I get a pretty straight line in the velocity time graph. I get a pretty horizontal line in the force graph. I get a pretty good horizontal line in the acceleration graph, and then strange things start happening. The velocity goes to 0, my force goes to 0, and that's one thing I want to watch, is that it actually goes to 0, which means my force probe is still calibrated, which is an issue. My acceleration actually dips below 0 and then comes back up. And so while the acceleration is pretty much horizontal, that's the region of interest. That's when it's just being pulled along. And so these other portions where acceleration goes up, or where it goes down, those portions I'm explicitly saying, when you do your analysis, don't even mention this stuff. Don't mention the dip. Don't mention the rise. All we're looking at is the area where the cart is being pulled along. We don't even want to acknowledge the existence of anything else. Okay? All right. So, looking at our data then, let's see, what is this asking of me? Let's see. Oh, how did it match your prediction? How does the acceleration vary during the region of interest? In the region of interest, it's that's the level part. Let's see. Use the linear fit on the velocity graph. So what's going on here is I'm going to say, all right, about 0.2 seconds. That's when my acceleration graph says, all right, I've finished releasing the cart. It's just being pulled along, and then I'm going to say maybe somewhere around 1.6, I guess, is when the cart catcher starts hitting that. So I'm going to go to pick a region between 1.4. Between 0.4 and 1.6. There we go. And but notice I did it on the acceleration graph. I shouldn't do that. I should do that on the velocity graph. So something somewhere around 0.4 out to 1.6. Okay, and then I want analyze linear fit. Okay, so if we were face to face, I would be asking you the question, how do we get the acceleration from a velocity time graph? And the answer, should be clear by now. It's the slope of the velocity time graph. And so if we look at m here, look at the slope, the 1.174 meters per second, that's meters per second squared. That is the average acceleration. If I hit Control E, and again for the acceleration, Control E. Okay, Control E. There we go. Okay, I should be able to go around, and yeah, it's hovering around that average, that 1.7. So sometimes it'll go above, sometimes below, but 1.7 is actually a pretty good average. All right, so what I'm going to do is find the point closest to 1.17. Closest that I can get. Actually, 1.15. That's pretty good. And so okay, so my time is going to be about 1. There we go. 1.17. That's even better. Okay, so I've got so at 1.15 seconds, my acceleration is 1.17, and my force is 1.1 1.163. So that 1.163, that's what you want to actually enter. So acceleration 1.17, force 1.163. Okay. All right. Let's see. What am I looking at? Oh, motion and force. Yeah. Okay. This is actually. Oh yeah. This is not the file that I should be using, but it's working. So hey, let's use it. The timing seems to be all right. Okay. So now, next thing, I'm going to move up to 180 grams. And let's see, we had let's see, what's the more efficient way to do? Yeah, I guess just get a couple more 20-gram masses. Put this on here. Wait for it to go to 0. Weigh it, see if I've done this correctly. 180, okay, we're good. So, that's going to be the next run. Okay, so my string is still in the wheels. That's a good thing. Let's bring it over here. Oh, whoops, I lost a... Okay, thank you. There we go. Lost a weight. All right, so let's go ahead and collect. All right, so so that was dramatic. Let's see. So let's adjust the force again. I'm going to hit A there. Okay, so there's our forces. I'm going to adjust for the velocity as well. I'm going to leave the acceleration as it is. And for the not what I wanted to do. Yeah, there we go. For the linear fit, I think I'm just going to move these brackets around. So now I've got the, let's see, actually I'm going to move it a little bit more. Okay, so now I've got the region where the acceleration is pretty much horizontal. My velocity is pretty straight. So let's see. I'm going to take this and move it over here so that I don't have to, so it's not blocking anything. So I'm going to hit Control E and Control E. Okay, so now my slope is 1.46 around, so I'm going to look for something close to 1.4. Okay, look for something close to 1.46, excellent. Okay, so basically at 0.65 seconds, my acceleration is about 1.46 and my force is about 1.407. Okay, so there's your data there. And then my, my last run for activity 3. Back. Okay, so now I'm going back to 100 grams. Oops. And so I'm taking my 20 gram weights off, and I think I've lost a 20 gram weight. Okay. All right. So just being excessive about this. I mean, we've already weighed this, but I'm just making sure I'm not making any errors. Okay, so got 100 grams on there. So I'm going to, oops. Okay. All right. So let's collect again. Okay. So, doing this again. Let's see. Maybe this should be over here. Why do I have this? What is this? That's weird. Anyway, okay, so I'm going to move my brackets around. Yeah. So yeah, to about 2.2, because that's where the acceleration begins to dip. And I'll move this bracket over here because that's where the acceleration is stabilized. And so now I've got a slope of 0.841. So that's the acceleration that I'm going to be looking for. 0.84 around. Control E for the force. Control E for the acceleration, and so I'm looking for an acceleration of 0.39. You know, that's close enough. So that means that the corresponding force is going to be 0.853. All right. So those are the that's the data for activity 3. And so what you do then is, okay, we've got a bunch of forces, a bunch of accelerations. This is an old version of that. Okay, so what you do is you set up a scale, and I'm probably going to get you a more up-to-date version, but anyway, for the maybe, well, anyway, you set up a scale so that on the y-axis you'll have accelerations. On the x-axis you'll have forces, and then you'll use the accelerations that you recorded here as your x components, the forces that you recorded there as your y components, and you draw dots for each of the runs that we did. Okay. All right. So then, and we want to look at the dots and see what they're doing, and then I'm going to include 0, 0 because we know that if there's no weights on the on the string, then there's going to be no force exerted. If there's no force exerted, there's going to be no acceleration. So we kind of get the 0, 0 point for free. All right, and we know that it's exact. So we want to go through that 0, 0 point and make a line as close to the other 3 points as you can. And then essentially write an equation for the line. And I want you to indicate what the variables in that equation mean. In other words, if you use a variation of y equals mx plus b, well, first of all, I'd want the numbers, the actual value for the slope, and the actual value for b in that equation, and then tell me what x and y mean. Okay, having said that, the next thing to do is go on to activity 4. Okay, so now let's do activity 4. And with activity 4, I'm taking my cart here and taking my large mass here and slipping it in, trying not to turn off my force probe. Okay, and then I'm going to weigh it. So let's see. Okay. All right. So I've got, here, I'm going to come around and look at it. All right, so 1.461 kilograms. So that's what we're working with this time. Okay. All right, so we're doing the same masses as before, and as I recall, the masses that we started out, the mass that we started out with was 140, and I'm just going to be extra careful and say, we've got we've got 140 again. Not surprising, but still. And all right. So let's attach things up. You can see from the graph that we zeroed the force probe. That's necessary from time to time. And then go ahead and hit collect. Okay. All right. So now doing the here. All right. So let's see. It appears that my acceleration settles down at, I guess about 0.5 seconds. So let's grab the bracket here and bring it to 0.5. And then it starts hitting the force probe at 2.2. So let's bring it back to 2.1. Okay. And with that, okay, we've got we now have an acceleration of 0.794 about, so 7935, and so let's do the Control E. So I'm going to look at 0.7, for 0.794. Let's see if I can get something close to that. I'm suddenly unable to see anything. 0.793. That looks pretty good. It's rare that you can actually get things this close. We've been looking out in this lab. Okay, so the force that I'm looking at then is 1.194. Okay. All right, so the next mass that I'm putting on there is 180. So I'm putting all the weights on there. And making sure I'm not screwing up. Okay, it settles down to 180. Okay, good. All right. Okay, so go ahead and hit collect. All right. Okay, so dramatic crash landing here, but that works. Okay, so let's adjust the parameters. Okay, so so looking at the acceleration, yeah, at 0.2 it's still kind of going up. So yeah, I think 0.5 is probably the better place. And I'm thinking, okay, here it's beginning to go down. That's the that's where the cart catcher is beginning to have an effect. So let's put this at like 1.8 around. Let's see, where am I? Okay, so then click on the force, go Control E, click on the acceleration, Control E. Okay, so I'm looking for a slope, for an acceleration of about 1. Let's see if how close I can get to 1. Oh, that's not too bad. That's better. Oh, that's very close. Okay, so so my acceleration is about 1.003, and the force is about 1.52. So okay, so that's the second run, and then for the third run, I reduce my mass down to 100 again. Okay, so with just the 50-gram mass on there. Okay, so I've got 100 grams. So, put that on here. One thing we have to make sure of is that the cart isn't low enough that it's scraping along the ramp. That happens a lot. Okay, So let's go ahead and hit collect. All right. So let's see. I think I'm going to adjust the velocity here. And maybe adjust the force. What the heck? And actually, maybe adjusting the acceleration in this case isn't too bad. Usually this dip really makes the adjusting the acceleration worthless, but it's not. The dip isn't too bad this time. Okay, so my acceleration is still settling down at around half a second. That's probably a measure of my reaction time. And then I'm going to interpret this as the initial stages of hitting the cart catcher. So I'm going to say let's look at 2.2 here as far as the final time. Okay, so then click on the force, Control E, click on the acceleration, Control E. So my slope is 0.5587. So I'm looking for something near 0.56. Okay, so looking at my accelerations here. Oh, 0.566. That's not too bad. That's not too bad. I'm wondering if I can do better though. 0.564. I think that's a little bit closer. Well, maybe I can get closer still. Shouldn't get greedy though. 0.57. It was 0.558, and here's 0. Oops. Where was it? Yeah, 0.557. So I think that's as close as I'm going to get. Okay, so my acceleration then is going to be 0.557, and my force is going to be 0.888. Okay. So, so again, we'll use those points, and create a graph here. And remember, you want the line to go through 0, 0, and then kind of pick the best point that best matches the line and use that as for calculating your slope, and then write the appropriate equation. Okay, then finally we come to here. So with activity 3, we've got a cart mass. Activity 4, we've got a cart mass. Activity by slope I mean the slope that you came up with for this thing. So you use the slope that you filled in here for this, and then same way with activity 4, the corresponding slope there, and then based on the table, write an equation that relates the forces and the forces, the accelerations, and the masses. Hint: the slope is what over what. Okay, so first of all, you'll have numbers in the mass column here. You'll have numbers in the slope column. So the question is, what's the relationship between the numbers in this column to that column? Okay. And keep in mind, this is an experiment. Anytime you do a measurement, you introduce errors. So there's going to be little errors there. So don't expect things to be exact. Okay. So so I would say write an equation that says cart mass has whatever relationship to slope. Okay. Then your slope, if we go back here, it says, put the force on the y-axis, put the acceleration on the x-axis. So the slope has a relationship to the force and the acceleration. And so what you want to do then is say, okay, I've got this relationship between the force and the acceleration and the slope, between the slope and the mass, and then kind of eliminate the slope in those two equations and relate the force and the acceleration to the cart mass. Okay, so that's the idea there. So when we're talking about slopes, when I'm talking about this the slope, I'm talking about these slopes here. All right, so that's that for that lab. See you next time.